Alright, I have started the recording now. Give me just one sec. Sorry about that. Technical
Oh, no worries.
difficulties. If you're
No
watching
worries
on
at all.
YouTube, we are now in kind of the middle of the presentation, but there was trouble with the recording, so we had to start over. So Rob's just going to run through really quick just the first sort of half of the presentation and get us caught up to where we currently are. And afterwards as well, this presentation will be posted in the meeting notes. So yeah, Rob, sorry about that, everybody. Take it away.
Sure. So, welcome to Inheritance, Unity, and Scriptable Objects. I'm Rob. I graduated from UConn last year, and I've since been working on various projects, including Scrapshoot, which is having a testing night, or a testing, I guess not night, but a testing day next Friday. Make sure to come to that if you're interested. So I'm going to be giving a little talk on some features of object-oriented programming and specifically Unity that I think are extremely useful and that can make your life a whole lot easier. So just to kind of skim through quickly, starting with inheritance. So inheritance is a way of making some base behavior in one class and then having other classes inherit that behavior. Uh, so the base class contains maybe a function that does X thing, and you want like three other classes all to be able to do X thing. Instead of rewriting that function or calling the function on the base class, and then getting the output from that back into the class you want, you can just inherit from it, and you'll have that function right in your script. So this helps keep your scripts shorter, and it lets you change that function rather than having to change the function you wrote once and then remember where you'd copied and pasted it to in all your other scripts. You just write the function once and it works fine. And you change it in the one place and it changes everywhere else. One of the other things that inheritance lets you do is polymorphism. So this lets you treat any inherited class, so any of those classes that have inherited that function, as if they are the base class, and it lets you treat them all as if they're the same class. So if I have those three classes that are all inheriting from the class with X function, I can say X function or X class, the base class dot X function, and I can input any of those child classes to that to that slot. And I can have any that variable contain any instances of the base class as long as I only need the behavior from the base class. And this to do that with functions, you use these keywords called virtual and override. So in the base class, you create a virtual function, and you give it whatever your default behavior is. And then if you want to change that behavior in the child class, then you rewrite the function, and you, instead of being a virtual function, you call it an override function. So it instead of doing whatever the base class does, it does something different. And you can also in that override function, you can call the base version of that class. So if you just need to add something, if you need to say do whatever the base class does and also move to the right, or also whatever other thing you need your function to do, then you can add that with an override as well. So I've got some examples for polymorphism. So this is the Scrapshoot uh, interactable object class. So this handles all of the interactions between objects, between the player and other players and things that are spawned on the ground. It handles all of those interactions. And this is the base class on the left here. So you can see interactable object, it inherits from Monobehaviour, so it can be attached as a component to your objects in the scene, your game objects. And it has some various fields on it. So you have the type, the team. You can see the team is referenced a lot in different classes to figure out if I'm You can even see it in here some places, that if you're checking if this object is on my team or on the enemy team, or if it's neutral. So having this in the base class makes it automatically anything that inherits from this will be on a team, or will be able to be placed on one team or the other. And then you've got this highlight system here, which means that. Oh, sorry about that. Oh no. Is the screen still shared? Yes, it is. Okay.
Yeah, you're good.
Okay. Yeah, so you've got this highlight class here, which means that anything that inherits from interactable object will be highlighted automatically when certain things are done. So you don't have to copy paste this whole property here and put it into the scrap class and the robot class and the player class and anything that needs to be interacted with. It just handles all of the highlighting for you. And if I need to change the highlight behavior, then I can change it here instead of having to change it everywhere else. And you've also got this virtual function here, which is activate. And this is the actual interaction part of the interactable object. And this, by default, is collapsed because it has a very long comment explaining what it does. But in the base class, it is an empty function. It does absolutely nothing. The only reason it's there is so that all of the base classes can override it. So this is the scrap class. This is just the upgrade or the resource that you pick up that lets you send robots across the map, and it inherits from interactable object with a colon there. So this has this because it's an interactable object. We know it has a type. In this case, the type is scrap. We know it has a team. We know that it highlights automatically when something can interact with it. But it also has all of these other behaviors, including this overrided activate function. So rather than being just the blank function in the base class, the overrided activate does all sorts of things when the player tries to interact with it. So if the player can pick up the scrap, it'll be destroyed and it'll increase their scrap counter. But those specifics aren't important. But what's important is that the player doesn't need to check for a piece of scrap and then check for a robot and then check for an upgrade or any of these things. It can just check for an interactable object, and if it finds one, call activate, and whatever kind of interactable object it found, that's the activate that will be called. So over here we have, this is the activate function for the robot class. You can see it's much more complicated, it's much longer, but just the same as the scrap, you don't have to check, okay, does this thing that I found have a robot class, in which case I need to activate this, or does it have a scrap, in which case I need to do this? You can just say, if it has an interactable object, I'm going to call activate on it, and it'll do whatever that activate does. So it's a very good way of treating all objects that inherit from a certain class as if they are that class. So you can just call it with activate, and hit object in this case just being it hit any interactable object. So moving from that, we're going to get into. Oh, I've lost my. Oh, that's fine. I lost my little slide preview when I minimized the presentation, but that's fine. So in C#, there's a tool that you can use with an inheritance called interfaces, and these are a way of they are essentially they're a contract that a class signs that says, I will include these functions, I will include these properties, and if you call this function, if you call this function on my class, it will exist. There will be some function in my class that you can call, and what function that is defined in the interface. And the nice thing about this, you can't define any kind of default behavior for it. So you can't say in the interface itself, the interface acts as a base class. So you can't say in the interface, for example, activate and then give it some behavior and say, if it's not overridden, I want to do this thing. That is a feature in a more recent version of C#, but Unity doesn't use that version, so you don't need to worry about it. So yeah, interfaces, they're a way of doing what's called multiple inheritance, which lets you not only inherit from the interactable object script or from whatever other script you've made, but it lets you then put other ways of interacting with this object. So if I go back to my examples earlier, you can see the scrap doesn't just inherit from interactable object. It also has iPooledObject and iPickUpMove. It's cut off there, but that's iPickUpMove. And these iPooledObject tells me that this object will have, for example, a pooler, and that it will have certain functions that the script will implement that are further down off the screen here. But I know that the strap class will have certain functions related to object pooling that can be called from it, and I don't need to worry about what kind of pooled object it is. I can just know that it's something that's pooled and use it that way. So for some examples, and there's also abstract classes, which are kind of a middle ground between interfaces and normal inheritance. They're available in most object-oriented programming languages. So interfaces are a C# specific feature. Abstract classes are available kind of in general, and they're like interfaces, but they let you define some default behavior, and they don't allow multiple inheritance. So you can only inherit from one abstract class, where you can inherit from multiple interfaces. Multiple inheritance is available in other languages like C++. C# just doesn't allow it outside of interfaces. So they're a way of getting some of the advantages of multiple inheritance without having the complication of treating one object as if it is multiple other kinds. And it's a kind of a category thing that C# just doesn't want to deal with. So for some interface examples, these on the left here, this is the Scrapshoot player input base system. So this is the entire interface. Interfaces are generally fairly short because they're just defining these blank, in this case, blank properties. So all I know is that there's a read-only, or there's a publicly accessible action, an attack bool, so I know if the player's hitting action or attack. And then there's a public vector3 that is the direction the player's moving in. And with that, any player movement component, anything that moves a player, instead of having to say, okay, look for a controller input component or an AI input component or whatever three others that might be there, it can just say, okay, look for an iPlayer input component. If there's one there, it'll have this action and attack and move vector, and we can just take that information from it. So we can, if I want to make a variant of my player that is controlled by an AI instead of a controller, then I can just replace this script instead of replacing all of the behavior and all of the scripts on the object. I can just swap out the input component and put in my new AI one. So you can see I've got this controller input component, which inherits from Monobehaviour, so it can act as a component on an object, which I'll get into a little later. It also inherits from this iPlayer input component here. And the I there is because it's an interface. It's a convention in C# to always start with an I for an interface, just so you know it's an interface. So yeah, you can see this has action, attack, and move vector, and these are assigned further down in this script. And you can see the AI input component derives from the same things, and it has these same properties, but they're defined, or they're assigned further down in the script in a completely different way. One of them is getting input from a controller, the other is generating those inputs through an AI. So on the other side of on the right side of the screen here, we've got just some other interfaces, and you can see they're very, very short classes, or they're not even, they're very short um, structs. Like they're a very short thing. They're very short scripts that they just contain their half of the contract, which is anything that inherits from this will have this conveyor movement vector in the move object, or in the move object function, or it'll have these functions. So it's just a way of saying this is a way of interacting with an object that I'm defining here, and if an object has this interface on it, then you can interact with it that way. So moving on from interfaces, we're going to get into the second half of this presentation, which is, so interfaces are a very useful tool. You can do a lot, or inheritance rather is a very useful tool. You can do a lot with it, but the thing that I think is more relevant to Unity, and specifically that a lot of people just don't really see because it's not covered in a lot of Unity documentation. Like if you're just looking for how to implement something specific, usually you won't see scriptable objects come up. You have to kind of go looking for them. So to start with, what is monobehavior? Right? It's the base class for components that anything that you put on a game object will inherit from monobehavior. So even when you make a new C# script, it automatically inherits from Monobehaviour, and if you want it not to, you have to change that yourself. So it gives you access to all of the functions that you expect on a component. It gives you start, update, fixed update, all of these things. It lets you reference the game object that you're attached to or the transform. It's got a whole range of different features that it gives you access to that are really helpful if you're making a component. But what if you don't want to make a component? What if you want to make a script that doesn't have to be attached to some object in your scene? If you just want to store some data, or you want to store, if you want some behavior that's just accessible without needing to be in the scene, you can go to scriptable objects. So these are the base Unity class for data and functions. So if you have some kind of data that you want to store, this is how you should store it. This is the best way to store it. So it's derived from the same base class as Monobehaviour. They both inherit from object, which gives them some behaviors in common. They can both be treated, if you've probably used like game object fields in a class, so you can say you can do things with a game object variable. You can do things with a scriptable object variable, or you can just say object, and you can drag any scriptable object or game object or monobehavior into it. So these cannot be attached to anything in your scene. They can't be instantiated. They are entirely in the project. They're in the asset side and not in the scene side of Unity. And they enable all sorts of design patterns. So what kind of patterns do they enable? There are three main ones that I'm going to talk about. The first is they help you make better singletons. So these singletons being basically a way of it's basically anything that you want to only have one of accessible at a time. So if you have your in the project, the game jam project we worked on last month, there was a wind manager that tells you which way the wind's pointing. You don't want to have three of those that are competing and pointing wind in different directions. So you keep a single singleton, and that just tells you what the wind's doing. They let you store data in the project, so you can have. And I'll go more into each of these later. We're kind of getting back into where we were before the restart. So the last thing before we get more into this is the create asset menu tag, which just lets you create an instance of whatever scriptable object you're using. So you can basically make a scriptable object. You can put certain data into it, and then um, yeah, you can put different data into it and use those in different places in your project without needing to have them in the scene. So you can, if I make a single instance of my object, I can put it into any scriptable object field anywhere in the project without needing it to be in the scene. So it's a really good way of decoupling scripts from each other. So that includes in prefabs where you could usually only include any dependencies that are in the prefab. This way you can include a scriptable object that includes whatever data you need and have it in the prefab itself. So when you drag the prefab into the scene, it's got everything it needs. So singletons, I've already more or less covered in the previous slide, but monobehaviour, you can make singletons and it works fine. You can make singletons that are just derived from nothing and that works okay, but you won't get access to certain functions of Unity classes. And for monobehaviour singletons, you have to be really careful not to accidentally drag two of whatever prefab is holding your singleton into the scene, or maybe you have it set to not destroy on load, and you load a second one, so now you have two competing. ScriptableObjects just let you automatically keep a single instance of that singleton, and I'll have some code for that I can show at the end. So the other main use of ScriptableObjects is storing data. So these are a couple of the classes that are used to store data in ScrapShoot. So you can see here it's got the create asset menu tag, and it says the default file name when I make this this asset is going to be game mode, and it goes in the menu, the first thing in the menu, and it's just new game mode. So you can right click in the project view, say create new game mode, and it'll just make one of these for you as an asset. And once you have that asset, you can change all of these variables. You can say, in this case, it's a game mode, so you can say, which upgrades do we want available, which events, which maps, and it just lets you define all of these things and assign that without needing to have a bunch of game mode objects in the scene, each of which has its own data, and it's a way of letting you do all of this on the data side and on the project side and not in a scene. So we've also got the robot upgrade stats here, which are a nice way of, and you can see they work the same way. You create the asset menu, and then you define all of these things, and you can put behavior into these scriptable objects. You can do anything you want. These happen to mostly have data stored, but these so they let you set all sorts of data about what robot upgrade is being used, and what so in the robot class there is a spot to put a robot upgrade stats object, and you drag whatever the appropriate upgrade stats scriptable object the appropriate instance is for that upgrade. So if you have the tank robot, it's got a tank variant of this with higher health and lower damage, that sort of thing. So the last thing that scriptable objects really let you do is remove out-of-prefab dependencies. So there are a few different ways that they do this. You can use them as a between scripts. You can have a data storage scriptable object, and just, let's say you need to look at, you could even use it for an input system if you really wanted to, or you can use it as a data manager, like a singleton. So you have some list of the available, let's say the all of the scrap. If you're trying to make an AI, you want a list of all of the things that the AI can interact with. So you could have a scriptable object that just stores that information, and instead of every piece of scrap that drops having to tell the AI directly, "Hey, add me to your list," you can instead go to the scriptable object and say, hey, add me to the list of possible things, and the AI can go to that same object and say, what do you have available? And it lets you, instead of every single scrap that you instantiate needing to be assigned to a robot, and needing the robot to have all these fields for scrap or whatever, however you're doing it, you can just do it. You can assign the same scriptable object to each of those prefabs, spawn in those prefabs, and just not worry about what function calls are happening across each, because they're both just looking at the same kind of middle layer that makes them just interact much more easily. So yeah, there are two ways to solve the dependency problem. Scriptable objects are the better one, because if you want to make a prefab that contains all of the dependencies, if I drag my player into the scene and hits play, and I'm getting an error that says, missing the wind manager, or missing the AI like object manager, then I need to drag all of those things in, and those have dependencies. So I drag, and suddenly, I'm trying to test some tweaks to the player movement, and I've had to recreate the entire main scene in this testing scene just to make like 5 small tweaks. Instead, you can use scriptable objects, and if there's no data in those scriptable objects, that's fine. They're still there. You don't get like a null reference. You can just you can focus on the specific features of that thing that you're trying to test. So, for an example of another way of making scriptable objects talk to each other, this is a game event system that I implemented in StrapShoot. So this is a very good way of removing dependencies from your game objects, and instead of having a game object that needs the UI system in it so that you can call a function on the UI system, what you can do is you can have a scriptable object with the asset menu. So, and this is some the order being -1,000 here is just a way of making sure that this stays at the very top, and it's got a whole kind of nested folder structure of the different scriptable objects and the game events. But it lets you create a game event and then register listeners to it, so you can have anything. So you basically, the listeners here, you create a script that just says, "Hey, tell me when this raise function is called on you," and it'll go through, and whenever the raise is called, it'll go through all of the listeners and call on event raised. And the listener function here, or the listener class here, is the game event listener, sorry, is the base class that any other listener. So you can derive from that, and you can get you can implement a listener directly in a script. You can just add it as its own component and assign the Unity event to it. So it's a very powerful way of decoupling dependencies from your other scripts. Yeah. So I'll, if you have any questions about that, I'm very happy to kind of go more into it at the end, which is now. So thank you for listening to my slightly disorganized, slightly rambly talk. And if you have any questions, now is a great time for them.
Thank you, Rob. I'm going to go ahead and stop the recording here. Actually, you know what? I'm not. A few people before actually asked that I do record the questions, but if anybody in the channel here is uncomfortable with recording the questions, let me know in the general chat, and I can stop the recording. But if everybody is comfortable with it, I'm going to leave it running.
Sure.
First of all, great talk. Really great talk. That was pretty fantastic.
It was a little bit condensed, a lot of different things, but hopefully, like I said at the start, hopefully, if nothing else, it gave you an idea of what to Google to get the kind of full depth of it.
Definitely. Do you have this presentation on like a Google Slides that we could share?
Yeah,
Cool.
yeah, I can send that to you afterwards.
Oh, very cool. But yeah, if there are no questions, uh, yay! Claire's clapping. I think there's a message in the
Rob.
general.
Oh, hello.
Hi. Can
Hello.
you inherit from like just like a class and then also interfaces? That's like one class and then
Yes.
on top of that. Very cool. Thank you.
Yeah, so that's the great thing about interfaces. And I think is it this one? No, this one. So the scrap here, you can see it inherits not only from the interactable object, so it gets all of these advantages here, but it also gets multiple interfaces. So you can you can interact with a piece of scrap as if it's or the pooling system can interact with it like it's any other pooled object. The pickup moving system can interact with it like it's any other like pickup object. So yeah, you can do all sorts of really cool things with this, where you're inheriting from some base class, and actually any component with an interface on it is both doing inheritance and interfaces because it's probably inheriting from monobehavior. So yeah, you can absolutely combine these and get even more functionality out of that.
Sick. Thank you.
If there are no other questions,
I've got sort of a really vague one, if you could
Sure.
humor me for a second.
of course.
What are the performance considerations of not the not inheritance, but of singletons and like creating assets that way as opposed to prefabs?
Yeah. So the so it is the main difference with scriptable objects. The nice thing about them is if you have they're not loaded into memory until something in the scene actually calls for them. So if you don't end up with if you have like 80 scriptable objects and none of them are referenced in the scene, you're not just using a bunch of unnecessary memory or anything. Um, they're only they're it's a very like highly performant way of making a singleton, especially I think it's probably about I don't know if there it's a performance advantage over a monobehavior singleton. I would be kind of surprised if it was, although it doesn't have some of the callbacks. Sorry, what was it? Oh no, gotcha. Yeah, yeah. So it doesn't have the update or fixed update callbacks. So there, if you want to do something in a singleton, like on the update loop or something like that, then you would use a monobehavior instead. But you probably don't want to do that in a singleton. Yeah, there. It's a very performant solution. It's yeah. I to be honest, I haven't gone that much into the performance side of it, but I've never had any issues with performance using scriptable objects.
Awesome, thank you.
Oh, and that reminds me. Let me find that the base scriptable singleton. I think I called it class that I think was used in the game jam this year for some of the wind stuff. It's a very nice way of basically it automatically checks if yeah, here it is. So it automatically checks. It's a base class that just contains an instance of itself. Here, let me switch the screen share. So this is the scriptable singleton base class. So it uses a generic, which is a whole other thing that's extremely helpful. That I guess it probably could have been in this talk, but it's not as inheritance related. This is just an abstract class that it derives from scriptable objects, and it contains an instance of itself. It contains an instance of whatever class it is, and this is static, so it's accessible from anywhere. You don't need a reference to a specific one of this object, and you can just get that instance. And if there isn't one already there, it'll make one. And then the next time something comes to this scriptable singleton and says, "Hey, I need an instance of whatever you are," it'll just get that one. So it's a way of automatically keeping a single singleton in your memory. Let me see. I think the wind doesn't actually inherit from it. There was something that that used that, and it was very helpful. And it's this. So yeah, so anything that needs the projectile target manager, this is a singleton of type projectile target manager, and it just has this information, and it'll say, if it just tells you, like, if you need an instance of this and there isn't one already, it'll create one. But if there's one that exists anywhere, it'll use that one. It's a really simple way of making singletons and making them consistent and safe to use. Yeah. Are there any other questions? No?
I think that concludes our talk for today. Thank you very much, Rob.
Thank you very much for hosting me.
If everybody could unmute and give Rob a clap. Just a little round of applause, maybe. I don't know. I think everybody's mic is only picking up half their claps. So it all just sounds like really disjointed, like it's just really good. Yeah, great talk. That was really fantastic. Thank you for presenting. Thank you for taking the time to come out.
Oh, of course. You can see me giving this exact talk at GDQ next year.
That'd be great. I'd go. I'd easily go. That'd be great.
Thank you.
Yeah. So yeah, that concludes for today. Feel free to use the meeting room or the dev zone if you guys would like to keep talking, keep on, maybe more questions if you have more ones that won't be recorded. For everybody watching on YouTube, thank you for watching. I'll try and get this up as quickly as I can. I'm assuming that if you're at the end of this video, I eventually did get it up, so that's good. You can join us every Friday from 2 to 4 p.m. Today was a reschedule of Saturday from 2 to 4 p.m. We only do reschedules if there are conflicts, but generally speaking, most meetings have been on Friday. So thank you everybody for coming. I will see you next week, where we will be having, if I remember, we'll be having Scrap Shoot playtesting next week. We'll be giving out beta keys for some lucky attendees, so if you would like to come and test our game, we'd love to have you. So yeah, I'm going to go ahead and end the recording here. Thank you.